Okay, so in this video I'd like to demonstrate how to work some of the homework problems on your homework section 3.4. So in this section we're putting together kind of all the little rules we learned in section 3.2 and 3.3. Where in synthetic division we were trying to learn how to find the zeros and how that looked on the graph, and we learned that zeros are the same thing as x-intercepts, are the same things as solutions to the equation. We also learned a lot of other little rules like the cut and bounce rule and various things about how to factor it, multiplicities, the conjugate zero theorem. So we'll see some of that in action here. So first of all, on number 1, it's multiple choice. Now you can use a graphing calculator and plug this in and also kind of look at the two and compare. But even without that, there's some clues that lets us know which one. And on this one, the end behavior, that's a big deal here, is the end behavior tells us because the lead coefficient is 1, positive 1, and the degree is third degree, the end behavior rules tell us that when you have a positive lead coefficient and an odd degree, that you go from down to up. So the graph starts low and then goes up high the other end. B is the only graph with the right end behavior. Also, we can blow this up and kind of look at some of the points and know that the last number, when it's in this expanded form, the last number is the y-intercept of the graph. And this looks like it could cross around positive 8. It's definitely crossing at a positive value. So that seems reasonable. Notice they're counting by ones horizontally and counting maybe by fives. I can swear to it, but they're not counting by ones vertically, and sometimes that will be a thing. Okay, so that's that one. Next, a similar question. It's a positive lead coefficient and an even multiplicity, or an even degree. Degree 4 means that it's an even degreed polynomial, and that means the ends go together, either both up or both down. So the ends should be together, and there's only one graph where that's happening. They should be together and also up. So graph C has up and up. If you needed to further analyze it, you could blow it up and look at it as well. But C has the only correct end behavior. Okay, now this is a conceptual question here to see if we're on the same page about what is a zero. A real zero means that it's the x-intercepts. The real zeros are the x-intercepts where it crosses the x-axis. We see it does that 1 time, 2 times, 3 times. There's 3 actual spots where we would call those x-intercepts. So we would say it has 3 real zeros. Number 4, back to the end behavior rules. Because it's negative, that flips the graph upside down. An odd degreed will be the ends are split. So the left side should be up and the right side down. So it could be this one or this one as far as end behavior rules go. So it's either A or C. When we blow up graph C, that might help us decide about the details here. It looks like it could be have too many turning points. For a third degree equation, you can have at most 2 turning points. So this looks like, and it's kind of hard to tell, I'll apologize for that, but it looks like that's a turning point here, here, and here. It looks like it wiggles across the x-axis in multiple spots, which means it also has more x-intercepts than would be allowed. Only 3 x-intercepts for third degree. So that looks like that's a problem. It also looks like the y-intercept could be at a negative number, and the y-intercept should be at positive 17. So graph C is looking more promising here. I'm going to say graph C looks to have the right end behavior and also have a y-intercept that could be at 17. On this one, we're actually going to use the graph, or we're going to multiple choice here, sorry. Which of the graphs cannot be that of a cubic polynomial? Cubic would be third degree, so a third degree polynomial can have at most 2 turning points. Additionally, it can have at most 3 solutions. Now, sometimes we don't see the full 3 solutions, but that's just the most it could have. So A is way out of the running because you've got 1, that would be a double solution where it bounces, so 2, 3, 4, 5 solutions. So that would have to be at least 5th degree. So that one's out. Now this one could be, it only has one x-intercept, but the ends split, like on an odd degree cubic polynomial. It would be a negative one, but that doesn't seem to be important on this question, just which could be cubic. So B could be. C is out because the ends go together. Also, there's too many x-intercepts, and but the end behaviors are up and up. That's an even degree polynomial, so that couldn't be. And then graph D could be cubic. We've got 1, 2, 3 x-intercepts, and the ends split. So B and D could be cubic. Oh, but the question is which cannot be, so kind of tricky there. Which could not be, so that would be A and C. I see there what I did. You've got to be careful to state the opposite, which could not be. All right. Next, we're talking about range. The range is the up and down. So the graph goes, like this one goes up to positive infinity and down to negative infinity. And the question, again, is stated kind of backwards. It says, which one of the graphs is that of a function whose range is not negative infinity to positive infinity? So this one does have a negative infinity to positive infinity. So does graph C, and so does graph D. Those odd degreed polynomials, like a cubic polynomial, will have a positive to negative infinity for the range as well as for the domain. But notice on graph B, it does have an ultimate lowest spot. I don't know exactly where that is right now, but I know there is a lowest spot. It's not negative infinity, but that's the lowest this graph goes, and then it goes up to positive infinity. So that one would not have an infinity range. Here we're factoring a polynomial. We can use these x-intercepts to help us figure that out. Whenever the graph just bounces off the axis, like we can see here, you might want to blow it up a little bit. So it looks like it bounces at -4. That means you're going to have the factor of x plus 4. And I need to take it to the second power, so I need to raise it to the second power. Again, because it bounces, a graph that bounces off the axis has an even multiplicity, and we'll assume it's 2 unless stated otherwise. It crosses through x is 0, so that's going to be x minus 0. Oops, didn't mean to hit the key there. It's going to be x minus 0, or just x. Notice if I put x minus 0 as a factor, that just looks weird. We usually just call that x, and when it's just an x, we put it in the front. So I will do that. One more thing. We cross at +6, so that means we're going to have a factor at the opposite sign, x minus 6. Now notice we always change the sign of where it crosses. If the solution in factored form is the opposite sign, x minus 6, when it crosses at +6. And then because the ends are up and up, I know it to have a positive lead coefficient. We'll assume that to be 1. But if these were down and down, I'd put a negative on the front of my graph. But this one is up and up, so positive. All right. Now number 8 is kind of tricky to graph on here. It asks us to plot a lot of points, which we usually don't have to do on these graphing problems. But this one does give us some practice with graphing. So to graph this polynomial, we're going to open up the graphing tool, and then we need to know what we suspect the shape is. Because this is x cubed, we expect it to have that shape, the x cubed shape. Now notice on this palette, it shows 4 points will need to be plotted to get a complete graph. Usually we don't have to plot a lot of points, I know, but this one does test us in our graphing of points. So we come over here and we plot our first point on our curve. Now, how do I pick this? And it's not very clear, I think, on the instructions. That's why I wanted to talk to you about this. How do we know where to start our 4 points we're going to plot? It would be good to get kind of something further over to the left, maybe to kind of know where the graph is on your scratch paper first before you come onto the computer and do this. Plot some points to kind of see where your graph is. So one thing I know about this graph is from our old style Chapter 2 work, the shifting rules tell us that the negative is going to flip it upside down. What's in parentheses moves it left, right. That's our horizontal shift of back 4. So we're going to have a back 4 and then up 2. I know that point is on the graph. And then it's going to be a negative kind of swirl this way from what we learned in Chapter 2. So kind of get an idea where you think your graph is. Since I know there's a pivotal point of shifting back 4 and up 2, that I want to make that maybe my second point. And you can see over here on the graph, it wants you to plot some on each side of where you think it turns. So I believe it turns right there. So I'd like a point over on this side. So a strategic point to plot would be x is negative 5. So I would plug in x is negative 5 on a t-table. Kind of do this on your scrap paper and plug it back in for x. You know, back up here, if we plug in a value for x like negative 5 plus 4 would be negative 1 cubed is still negative 1. Then the negative of negative 1 makes positive 1 plus 2 is 3. So that's 1 point I know on this graph. Back 5 should be up 3. Make sure you hit that point. Now I need maybe that negative 4, 2 point that I knew was on the graph. So I've got negative 4 and 2, and I need 2 more points. So let's do negative 3. Let's see where negative 3 is in the y value. So plug negative 3 in for x. So I'll go back up here. Negative 3 plus 4 is 1. 1 cubed is 1. Negative 1 plus 2 is positive 1. So negative 3 has a value of 1. I need 1 more point. Okay, so let's plug in, let's say, I don't know, I'm feeling negative 1 here. Plug in negative 1, but it could be any point that you like. If I plug in negative 1 plus 4, that's 3. Oh, I don't know if this will fit on my graph, so this comes up sometimes too. Let's see, negative 1 plus 4 would make 3. 3 cubed is 27. Negative 27 plus 2 is negative 25. There's a problem there because it only goes up to 10. So I call this sort of shopping for a point. At negative 1, the graph is so high I can't use my little grid here. Nothing wrong with that point. It's just the computer can't handle it. So I'm going to go to negative 2 and see what y value I need at negative 2. So back to the drawing board. Negative 2 for x. Negative 2 plus 4 is 2. Then 2 cubed is 8. Then the negative sign makes it negative 8. Negative 8 plus 2. Negative 8 plus 2 is negative 6. So at negative 2, I have negative 6. Oh, I hope I got all of those are correct. You know, number crunching can get you in trouble, right? So that arithmetic. Hopefully you all use your calculator and the such. Let's see if I made it. All right, let's check that answer. Yay. Okay, nice job. So that's kind of a tough one, I feel like, to get those exact points somewhere that you can find 4 good points that will be usable in a 10 by 10 grid that they've given you to work in. So the computer there does make that one a little bit tougher to sketch your graph. Then the next question is the function is increasing for what interval? So if you lay your pencil or marker or something along this curve, like lay it down there, that is a negative slant. And it's actually negative slant if I lay it any place. Say over on this point of the curve, it's also a negative slant. I know it's going up and down in the big picture, but in the little picture, laying your pencil along any point along this curve, your pencil is going to be headed in a negative, what we consider a negative slope direction. So we say that is our negative infinity to positive infinity for that answer. All right, I hope that helps. Oh, whoops, I'll have to, the function is increasing. Sorry, it's never increasing. I just got through saying it's all decreasing. So it's this one, the function is not increasing. Sorry about that. I need to read my directions closer, don't I? All right, hope that helps. I'll pause here, and if you have further questions, let me know.